Well, welcome back, and let's look at the last of our carbonyl containing functional groups that we're going to be looking at this stage. And this is, of course, the carboxylic acids. And we've come across these molecules before, and you may remember it as ethanoic acid. Okay, so ethanoic acid we've seen as being CH3COOH. Hopefully now you've known enough that perhaps you can start to pull this apart. You can see that it has eth, so the ethanoic, so eth means two carbons. Enoic acid is what we're going to give the ending of these molecules that have the COOH functional group. So let's start having a look at these. Carboxylic acids are organic acids, so we're looking at organic chemistry, but that means that they are compounds that act just like acids. Okay, so in this case, the hydrogen atom that we see here is an acidic proton, so this can be donated. Okay, it can be donated to solution to form H+. So it will act in the same way as an acid does for acid and base reactions, but all carboxylic acid containing groups are weak acids. Okay, so they'll form their acid plus their conjugate base, and the conjugate base, of course, will be the anion that we are familiar with, such as ethanoate, the anion. So this is the only of the acidic, one of the acidic organic compounds that we're going to look at. So just remember, when you're looking at these, you need to remember that they act as acids, which means that if I add this to a solution of sodium carbonate, okay, so Na2CO3, I'm going to have that acid plus metal carbonate reaction, which means I'm going to start to see bubbles of CO2 forming. So if I wanted to check between different organic compounds and I thought one of them might be a carboxylic acid, one way that I could test for that is to see how it reacted with a solution of sodium carbonate, because our alcohol and our aldehydes won't react with the base, so we won't see the acid. So it's a quick way that we could tell between them. So when we name these, we tend to look at monocarboxylic acids for the most part. So they contain one carboxylic acid group, okay, which means we look for the longest contiguous carbon chain, as we always have, and this must contain the carboxyl group, okay. So where we had a carbonyl just being the C double bond O, this C double bond O OH is what we refer to as a carboxyl group. The name of the functional group is a carboxyl. The name of the family is carboxylic acids. Okay, so when we do this, we then drop the E from the longest chain and then change it to oic acid. So when we have a look at this, acetic acid, which is the old name, would now be known as ethanoic acid because it has the two carbons in the longest chain, which means that we will then have eth as our prefix, and then dropping the E from the N, we would then have ethanoic acid. So another table for you to fill in, see how you go, and then come back and check your answers. Okay, so here we have yet another table of organic compounds, this time the carboxylic acid homologous series, and hopefully yours looks something like this. Just remembering that we do need to include all our hydrogens on our structures. Even if you miss one, you're going to lose the mark on your exams. So always double check there's 4 bonds around your carbon, and that you have drawn them in a zigzag conformation. So as you can see here, the molecular formula goes up by CH2 each time, so we know they're in the same homologous series. And hopefully you realized that the general formula for these is CnH2nO2, because we've got 2 oxygens in our carboxylic acid. So the melting point of carboxylic acids is an interesting one. As you can see, in each carboxylic acid functional group, we have a hydroxyl. We have this OH group, which means that it can form hydrogen bonds. So what carboxylic acids tend to do is pair up, and when we have those pairing up, we call them dimers, okay? Which means that because they are these dimers of paired carboxylic acids, they tend to form higher melting points. We've got strong hydrogen bonding, they're paired up, they're nice and stable, so they're generally liquids or solids at room temperature with very low volatility. When they dissolve in water, though, they don't form dimers because they can form these hydrogen bonds with water. So they'll form a hydrogen bond between the partially positive hydrogen on the carboxylic acid and the partially negative oxygen on an adjacent water molecule. They can also form another hydrogen bond between the C double bond O of the carboxyl group and the partial positive of an adjacent water molecule. So they get to form 2 hydrogen bonds per molecule, which, as you expect, makes them quite soluble, particularly for the smaller ones. Again, as we get larger molecules, those larger hydrophobic chains or non-polar chains tend to reduce our solubility. Okay, so that's it for carboxylic acids, and we will do other functional groups in our next video.